So in this second lecture, we'll start from valency. So in first lecture, we have seen few concepts related to atom. What are the subatomic particles present in the atom? We have seen regarding electron, proton, neutron. Then J.J. Thomson atomic model, drawbacks, Rutherford's atomic model. In this conclusions, observations, futures of Rutherford's model and drawbacks, followed by Niels Bohr atomic structure. Then we have seen different types of orbits and how many electrons are present in each orbit. Then we have seen concepts regarding shell 1, shell 2, shell 3. Then in this lecture, we need to start from valency. So basically what is meant by valency? An atom is stable if it has duplet or octet electronic configuration. Duplet in the sense in outermost orbit, 2 electrons should be present. Octet in the sense in outermost orbit, 8 electrons should be present. A duplet or octet configuration is also known as noble gas structure or noble gas configuration. In periodic table, we have 118 elements. In these 118 elements, 6 atoms are stable. I mean, 6 elements are stable. Remaining 112 elements are unstable. What these 112 elements will be doing means to get stability, it will be combining with other elements. It might share it electron, it might transfer electrons, like the ionic bonds, covalent bonds. We can able to see those types of bonds in grade 10. That is in chapter 3 and chapter 4 we can observe. Then here there are 6 stable elements. I said those 6 stable elements are helium atomic number 2, neon atomic number 10, argon atomic number 18, krypton atomic number 36, xenon atomic number 54, and radon atomic number 86. These are 6 stability elements where it will be following duplet or octet. Here only helium will be following duplet, remaining all other elements will be following octet. And if you write a general electronic configuration of octet configuration is NS2 NP6. So what is the 10s2 NP6 in the sense, if you write electronic configuration of helium, it is 10. 10 means we can write it as 1s2, 2s2, 2p6. You see here, this is outermost orbit. Here it is like 2s2, 2p6. Means in place of n, if you are substituting 2, it is becoming 2s2, 2p6. Now if you see atomic number of argon, it is 18. And if you write electronic configuration for 18, it is 1s2, 2s2, 2p6, 3s2, 3p6. And here if you observe, this is outermost orbit where 3s2, 3p6 means in place of n, if you substitute 3, it becomes 3s2, 3p6. Same like that for krypton, if you write, definitely it will be 4s2, 4p6. If you write for xenon, outermost orbit will be 5s2, 5p6. If you write electronic configuration for radon, outermost orbit will be 6s2, 6p6. This is the outermost electronic configuration. And if you observe, what is that 2 is representing 2 and this 2 representing orbit number, and this 2 plus 6 is representing electron count. 6 plus 2, 8. 8 stands for octa. And 3 is representing orbit number, 2 plus 6 representing electron count. 4 is representing orbit number, 2 plus 6, 8 electrons. 5 is representing orbit number, 2 plus 6, 8 electrons, 2 plus 6, 8 electrons. So in outermost orbit, here they have given atoms of other noble gases have 8 valency electrons. So outermost orbit, if there are 8 electrons, that is known as octet configuration, and these elements will be following octet configuration. So that is the concept of octet. And while coming to valency, it is combining capacity. Here they have given the combining capacity of the atom of elements, or that is tendency to react and form molecule. Why molecules are formed in third chapter we have discussed. Why molecules are formed in the sense to get stable. It is quite simple. For example, I'll tell you, if it is carbon dioxide, CO2, here carbon's atomic number is 6 and it needs 4 electrons to get stable. Oxygen atomic number is 8. 8 needs 2 electrons to get stable. So one carbon will combine with 2 oxygens. Here one oxygen, here one oxygen. Like that, carbon dioxide is formed. Like that, it can share its electron. So how many electrons needed, that we can call it as valency in simple words. Then here they have given another concept. An outermost shell which has 8 electrons is said to possess octet. Yes, already we have seen. Atom does react so as to achieve an octet in the outermost shell. This is done by sharing, gaining, or losing electron. For example, if you see sodium chloride, formation of sodium chloride. Sodium atomic number is 11. Chlorine atomic number is 17. You see 11 is not stable. Nearest stability element is 10, neon. 17 is not stable. Nearest stability element is 18, argon. Now sodium 11 has to become 10. How it can become means by losing one electron. So sodium will lose one electron. After losing this 11 becomes 10. It is stable. Chlorine, so this electron is there, right? That electron goes to chlorine. So that 17 electrons, now it has become 18. Now it has attained 18 electronic configuration. Simply to say atomic number 10, neon, atomic number 18, argon. Like that, elements will be losing electrons to get stable, gaining electrons to get stable, sharing electrons to get stable, and clear-cut information you will be getting in 10th class but not in 9th. So just try to understand the concept. Now, so here also they have given some example, lithium. Now, okay, this we'll discuss. Next concept we need to discuss about formation of cations and anions. Now we'll discuss formation of cations and anions. It is quite simple. So before telling about cation, anion, we should have some idea. You see in 8th class physics, chemical effects and these chapters, there we have studied for battery there will be two terminals, positive terminal and negative terminal. Negative terminal we have to call it as cathode. Just try to understand these names. Cathode. Positive terminal we have to call it as anode. That's it. Positive means anode, negative means cathode. Now you see in 6th class we have studied one concept that always positive charges will be moving towards negative. I mean positive will be attracting negative, negative will be attracting positive. That's it now. I mean in magnetism also, north pole will be attracted towards south pole will be attracted towards north pole. Simply to say, unlike poles attract, unlike poles attract, same like that, unlike charges attract. So positive will be attracting by negative, negative will be attracting by positive, positive will move towards negative, negative will move towards positive, because they are unlike charges, not same. If it is same charges, it will repel. Like charges will repel. Like positive you keep, both will repel. Negative you keep, both will repel. Like charges will repel, unlike charges will attract. Same like that. Just try to understand this concept. I'll explain what is that cation, what is that anion. Now you see, let us see a few examples like sodium. As I said, sodium atomic number is 11. 11 is not stable. Why? Because in periodic table we have 118 elements. I said in these 118 elements only 6 elements are stable. What are those 6 elements? Helium, neon. Here you can observe helium, neon, argon, krypton, xenon, radon. These are only 6 elements which are stable. And you have to remember these numbers also, at least 2, 10, 18, 36. Just try to remember these 4 numbers. These 4 numbers are stability numbers in periodic table. Not 4, 6 elements, 6 numbers. 2, 10, 18, 36, 54, 86. These numbers are stable numbers. Out of 118, 6 elements are stable. Now, what we have to do, whatever it may be the atomic number, we have to compare. You see, whenever one element is given for you, for that element there will be atomic number. What you have to do with that atomic number means, you have to compare that atomic number with the stability number. You have to compare that atomic number with stability number. What are those stability numbers? 2, 10, 18, 36. I told you to remember at least these 4, such that we can compare. Now you see, sodium atomic number is 11. Is that 11 stable? Means you have to remember those numbers, not 2, 10, 18, 36. Now we have to compare 11 with these numbers. 11 is not there in this list. Okay, next what we have to do? At least we have to see nearest stability number. For 11, 10 is near, not 2, not 18. Okay, 11 has to become 10. How 11 can become 10 means 11 minus 1 is equal to 10. Simple. 11 minus 1. So what is that? Minus 1 means minus stands for losing. 1 stands for losing 1 electron. Okay, I'll tell another example. Magnesium Magnesium atomic number is 12. Is the 12 stable? Means we have to compare with numbers. What numbers? 2, 10, 18, 36. Is 12 in that list? No, it is not there in the list. What we have to do? We have to go with nearest stability number. For 12, nearest stability number is 10. Now 12 has to become 10. How? Minus 2. 12 minus 2 is equal to 10. What is this minus representing? Minus is representing losing. And 2 is representing what? Losing 2 electrons. Magnesium, after losing 2 electrons, it is becoming 10. So that it will become stable. Another example I will tell you. Chlorine. Atomic number is 17. Is that 17 stable? We don't know. Let us compare with stability numbers. What are those stability numbers? 2, 10, 18, 36. Is 17 in that list? No, it is not there. What we have to do then? We have to compare that number with the nearest number. 17, if you compare with 18, yes, we can compare with 18. That is only near. Now 17 has to become 18. How it is possible? Plus 1. 17 plus 1 is equal to 18. This plus is representing gaining. Whereas here minus is representing losing, plus is representing gaining. Gaining what? Gaining 1. 1 in the sense 1 electron. Gaining 1 electron. Now here you see, whenever an atom is losing, you have to represent with plus. Try to understand. Losing means plus, gaining means minus. So Na, after losing electron, we have to write it as plus. How many electrons? 1. You can represent either plus 1 or you can leave it, no worries. Na plus. Magnesium, it is losing na. If it is losing electron, it is plus na. So Mg plus. How many electrons? 2. Mg plus 2. Or you can represent it as Mg2 plus. Both are correct. Mg2 plus, Mg plus 2. What is that plus is representing? Losing. 2 is representing number of electrons. So magnesium is losing 2 electrons. Now you see chlorine. Chlorine, Cl, gaining. Gaining means minus. How many? 1 electron. You can represent 1 or you no need to represent 1. Like that you can do it. Now another example I will tell you. Oxygen. Atomic number is 8. Is that 8 stable? Let us compare with 2, 10, 18, 36. 8 is very near to 10. Now 8 has to become 10. How? Plus 2. 8 plus 2 is equal to 10. Plus is representing what? Gaining. Gaining. 2 is representing 2 electrons. Now how to represent that oxygen? Oh, it is gaining. Gaining in the sense it is minus. So minus. How many electrons? 2. O minus 2 or O2 minus. Like that you have to represent plus minus on atom. Now if atom is having equal number of electrons and protons, I mean simply to say, before losing or gaining electrons, we have to call it as atom. That's it. Before losing or gaining electrons, we have to call it as atom. After losing or gaining electrons, we have to call it as ions. Before losing, gaining electron, it is atom. After losing, gaining electrons, it is known as ion. Now there are 2 types of ions. First one is cation. Here you can observe cation. Second one is anion. Let us see the difference between cation and anion. So I told you before learning about cation, anion, I told you to remember cathode and anode. If you can remember, this positive terminal is known as anode and negative terminal is known as cathode. Just a simple logic here. And also I told you another thing. Always negative charges will move towards positive and positive charges will move towards negative. Now you see, for example, chlorine, Cl, we have got chlorine minus, Cl minus. This is negative. Negative, always it will move towards positive terminal, simple. Because it is negative charge, negative charges will move towards positive. And I told you Na after losing electron, it has become Na plus. This is plus. Plus always will be moving towards negative terminal. So ions which are positively charged, it is moving towards negative terminal. Negative terminal is known as cathode and positive charges moving towards cathode. So positive charged atoms are known as cations. Simple to understand. cations will move towards cathode. And you see chlorine, it is negative. It is moving towards positive terminal. Positive terminal is known as anode. What will be moving towards anode? Anions will be moving towards anode. Anion towards anode, cations towards cathode. Here, they have given like, you see cations. If an element has 1, 2, 3 electrons in outermost shell of its atom, then it loses these electrons to achieve what? Noble gas electronic configuration. So positively charged ion known as cation. Why? Because you see positive charged ions known as cations they have given. Positive charged ions will move towards negative terminal. Negative terminal is known as cathode, so that positive ions are known as cations. Here you see anion. Here they have given negatively charged ion called anion. Why negatively charged? Here you can observe chlorine minus. Negatively charged ion will move towards positive terminal. Positive terminal is known as anode. So that negative charged particles are, negative charged atoms are anion. Sorry, it is not negatively charged particle. Negatively charged particle is electron. That is negatively charged atom. That is anion. That is the difference between cation and anion. Next topic is atomic number and mass number. It is quite simple. Atomic number is the number of protons of an atom. If you take an atom, there will be electrons, protons, and neutrons. Electrons easily can be removed, easily can be added, it can lose, it can gain, so that we cannot depend on electron count. And while coming to neutron, in few atoms, proton count, neutron count will be equal, and in few other atoms, proton count, neutron count will not be equal. That is naturally found. So we cannot depend on neutron also. Proton count is always stable, so that atomic number, in the sense we are going with number of protons only. For example, number 1 hydrogen. Why can we tell number 1 hydrogen? Atomic number 1 is hydrogen because hydrogen has 1 proton. Number 2, atomic number 2 is helium. Why? Because it has 2 protons. Atomic number 4 is beryllium because it has 4 protons. Atomic number 8 is oxygen because it has 8 protons. Atomic number 30 is zinc because it has 30 protons. Atomic number is nothing but proton count, and that atomic number is represented with capital Z. So nothing is there to learn more than this. Atomic number means number of proton. That is the thing you have to write it, and it is represented with Z. Next, mass number. Mass number is known as, in atom again we have electrons, protons, and neutrons. If you can see the table which we have discussed in last lecture, this table, relative mass, proton and neutron has greater mass in the sense 1 unit, but while coming to electron, it is 1 by 1838 times. 1838 electron mass is equal to 1 proton mass. You see how much negligible that electron is. Protons and neutrons are having greater mass when compared to electron. So 1837 or 38 electrons mass is equal to 1 proton mass or 1 neutron mass. That much heavier proton and neutron, and that much lighter electron is. So while coming to mass number is a combination of proton and neutron. Proton count plus neutron count is known as mass number. They are not taking electron count because it is not stable. Basically it is negligible in mass, very negligible in mass. You see, proton and neutron are also called as nucleons. Why? Because they are present in nucleus. The mass number of an atom is given by sum in the sense plus, sum of masses of proton and neutron. So proton mass, neutron mass, if you add, it becomes not only proton mass, proton count, proton mass, both are same only, because if there are 1 proton, we can call 1 unit, 2 protons, 2 units, 3 protons, 3 units. So mass and count both are same only. And so the mass number is defined as the sum of the total number of, you see, not only mass, sum of the total number of protons and neutrons present in the nucleus of an atom. In nucleus there will be protons and neutrons. Now if we combine together, we will get mass number. And mass number, here they have given some example like okay, here you see mass number is represented with the letter A. atomic number is represented with the letter Z. So here we have to draw like symbol with atomic number and mass number. So we have to remember atomic number is represented with Z, mass number is represented with A. Then, for example, from the knowledge of atomic number and mass number of an element, the number of electrons, protons, neutrons can be easily predicted. How? You see, atomic number Z is nothing but number of protons. Number of protons will be equal to number of neutrons. Like that, we can tell proton count and electron count. For example, if I tell 8 is atomic number of oxygen, easily can tell it has 8 protons as well as it has 8 electrons. Done with that. So by observing atomic number, we can go with proton count, electron count, both are same. Next, mass number. How? Number of protons plus number of neutrons. So mass number A is equal to proton count plus neutron count. From this, if you need neutron count, N if you need, send that Z that side. If you send that Z that side, it becomes A minus Z, which is equal to N. So number of neutron, N, is equal to mass number minus atomic number. This A is mass number minus atomic number. Simple. We will get neutron count. Now we have to discuss about isotopes. Isotopes are defined as atoms of same element. That is most important. Atoms of same element means element should be same. For example, here you see we have hydrogen, hydrogen, hydrogen. All are same elements having same atomic number. Atomic number is same means number of electron you see or number of protons you see. We have only one proton. Here we have one proton. Here we have one proton. Same atomic number means hydrogen atomic number 1, hydrogen atomic number 1, hydrogen atomic number 1. We have same atomic number but different mass number. Why? Because of addition of neutron. Naturally it is happened. This is neutron. This is neutron. This is neutron. Here 0 neutron. Here 1 neutron. Here 2 neutrons. Right. Now what is the mass? Here mass is 1 for this hydrogen because number of proton 1, so that mass 1. Now coming to second one, protons 1 but neutron 1, proton 1 na, so mass is 2. And while coming to third one, atomic number is 1 because it has only one proton but mass number will be 1, 2, 3 because 1 proton and 2 neutrons 3. So you can write it as hydrogen 1, 1, hydrogen 1, 2, hydrogen 1, 3. So it is defined as atoms of same element, hydrogen, 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 same element with same atomic number 1, 1, 1, same atomic number but different mass number 1, 2, 3 like that. That is known as isotope. And no need of all these, nothing needed here. This is not there in your textbook. No need to learn. Characteristics of isotopes. All isotopes are electrically neutral. All isotopes of an element show similar chemical properties. Why? Because atomic numbers are same. Because of same atomic number, same chemical properties. All isotopes of an element show different physical properties. Why? Because mass numbers are different because of addition of neutrons. Mass number of different isotopes of an element are different. Different mass numbers, different isotopes are different. All isotopes of an element show same valency. Why? Because atomic numbers are same na, so that same valency it will show. That is about isotopes. And there are uses of isotopes in your textbook. So isotopes are used in treatment of cancer. Carbon isotope is used to detect the age of a material, and iodine isotope is used to treat goiter of thyroid gland. These are used. And some cobalt is used in treatment of cancer. These are uses of isotopes: carbon isotope, iodine isotope, cobalt isotope. So these are concepts present in chapter 4, structure of the atom. Of course, we have isobars also in textbook. Once we'll see that isobars and isotopes once. So this is textbook chapter 4, structure of the atom, where you can find introduction. Then you can find this charged particles in matter regarding electron, proton, and neutron. And next, structure of the atom, where we have discussed about Thomson atomic model and diagram related to Thomson. Here we have Rutherford's atomic model. So you have to read everything, all these points, postulates, everything you have to read. This is gold foil experiment experiment, go alpha ray scattering experiment. Then there are drawbacks and some few points. These drawbacks are important, you have to learn it. Then we have a Bohr's model of an atom, Niels Bohr atomic structure. And then this is a representation of shells, K shell, L shell, M shell, N shell, and energy levels that and all. And neutron, just a small paragraph regarding neutron. James Chadwick discovered another subatomic particle with no charge. And then we have how electrons are distributed in orbits. So these are the concepts we have discussed, where 2n square will be used, that formula, and that is applicable only up to 4 orbits. And then this is the atomic structure you can observe by writing electronic configuration. So we know electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. This is the electronic configuration up to zinc. And valency, we have discussed about valency, combining capacity of an element. And they have given, you see, hydrogen with symbol atomic number 1. That atomic number is representing proton count. Helium atomic number 2, proton count 2. Beryllium atomic number 4, proton count 4. But you see number of neutron. In hydrogen we have 1 proton but no neutrons. Helium we have 2 protons, 2 neutrons, that is fine. But while coming to lithium, it has 3 protons and we think that there will be 3 neutrons. No, it has 4 neutrons. So we cannot depend on neutrons. So that number of protons only we are taking as atomic number. Then mass number is combination of protons and neutrons. And we have valencies here that we can see. And coming to the next point, we have to discuss about isotopes and isobars. Let it load. Fine. Atomic number, okay, isotopes. Here also we have discussed hydrogen isotope, na? H11, H12, H13. Not only that, we can find C, carbon 612, and here carbon 614. So same atomic number but different mass number. Here we have chlorine 1735, and another chlorine 1737. Masses are different, same numbers, same number, same symbols. Next, we have application. Okay, where we can use isotopes in the sense. Here you see, an isotope of uranium is used as fuel in nuclear reactors. Isotope of cobalt is used in treatment of cancer. Isotope of iodine is used in treatment of goiter, which will be present in thyroid gland. Next, while coming to isobars, that is the last topic. Isobars means atoms of different elements. You see, atoms of different elements. Let us consider 2 atoms: calcium atomic number 20, Ca atomic number 20, and argon, Ar, argon atomic number 18. You see, atoms of different element. In isotopes we are taking atoms of same element. In isobars we are taking atoms of different elements with different atomic numbers. You see, here we have 20, here we have 18. Yes, atomic numbers are also different, which have same mass number. Mass number is here they have given, each has 40, 20, 40, 18, 40. Same mass number, that is known as isobar. We don't have any application of isobar. So that is a concept we have to understand. That's it in this lecture, and we have completed this chapter.